recorded. I have a recording of that lecture anyway, so. Um, the point of the project is not the coding, okay? The point of the project is the analysis of your results. But you're going to write programs, well, write one big program. Okay. No, I wasn't talking because I was, coughing. All right, these are like the big three comparison sorts that use divide. Well, heap sort doesn't use divide and conquer. Okay, so you're going to randomly generate a large array of integers. I think I put 10,000 integers. And you're going to run it like 1,000 times with at least three of these. So you must do insertion sort. What's the runtime on insertion sort?
N squared.
N squared. What's the runtime on merge sort?
And n log n.
N log n. What's the runtime on quick sort?
Also n log n.
Okay. Best and average are in log n. On the not fixed version, there's a worst case, which is n squared. That's why we have the fixed versions. The original naive version of quicksort just picks out the first element of the array as a pivot. There are some algorithms, some versions of the algorithm that change that a little bit to minimize the chance of the worst case. And that's where you pick a random element from the array each time, or the midpoint of the array each time. That doesn't guarantee you won't get a worst case. It just makes it extremely unlikely. Like you would have to be the most unlucky person in the world to always pick the worst possible pivot. It could happen, but the probability is very close to zero, particularly on a large array, because it's like 2 to the n over n factorial. That goes to zero. And then heap sort, my favorite. I love heap sort. Anyone remember what heap sort is? Nobody?
I'm sorry, but doesn't heap sort automatically sort it when you add it to the heap? Is that what it
No,
does? No?
it doesn't automatically sort it. It puts it in a top-down hierarchy. But you can then repeatedly delete from the heap and that sorts it. The
So
building the heap is going to cost you n times, n time. That's linear. The deleting n times is going to be n log n. So the overall runtime is n log n. Heaps are just my favorite structure. They're super cool. I like heap sort because it doesn't require any additional storage, unlike merge sort. And it's also not recursive. So it's not using a lot of operating system time. Um, and what I want you to do with these is you're going to run, like I said, you're going to run the program like a zillion times and get averages. Clocks, actual clocks. So you're going to add timers to your code. Yeah, we're back to the posting the recordings. Today I messed up, so I have to get the recording from last fall. But since I already have the date up, it'll be easy to find. I don't know what that was. That sounded like a buffalo in the background. So we're going to put actual clocks into the code to get an actual CPU time. Which you're going to be amazed at how fast this stuff runs. I mean, it's running in milliseconds, 4 milliseconds or something to run these sorts. They're very quick. But, we have this n squared, n log n, best worst case stuff going on with quicksort. How do these all compare? I don't care. Okay. And when I say I don't care, I really do mean it. In a way, I kind of do care just because I like to get answers in both languages. You can use either Java or C++. I do want to know what kind of processor you used to see what impact that had on your runtimes. You see you have different, no, not Python. Python is an atrocious runtime. I know that you like Python because it's easy to write, but Python, there are no defined types, and so it's messy. It doesn't know what it's dealing with. I'm fine with just using integers on these. Um, I just don't want people trying, well, we could. Um, I'll think about adding a little bonus question on at some point to look at how making these into objects would change something. I had a student many years ago. Um, I had taught her for a whole lot of classes. I had her for 220, 313, 323, 343, 361. Um, and then she graduated, she went to Princeton for her graduate work. And one morning, like 2 years after she graduated, I got an email from her that was help. So it was like, all right, what's going on? And she was writing a project well, she just told me she was trying to sort 5 million pieces of 5 million objects. It was for a DNA analysis clustering. And she wanted to sort these 5 million things, and she was using quick sort, and she blew the memory. So I was like, why did you use quick sort? I'm going to go back and change your grade in some class for this. Quick sort is recursive, it's going to blow. You're going to kill this, and particularly this was like 10 years ago. So you're going to kill your recursive stack. So I said, you know what, do heap sort and run it. So the next morning I got a thing, oh, thank you so much, Professor. It ran in like 25 minutes. I don't remember the actual times anymore, but it was something like that, 20, 30 minutes. I had my top 5% in 25 minutes. And I was like, if you only want the top 5%, why are you sorting? Why not just extract 5% of the data using heaps? And the next morning, oh, thank you, Professor. I had it in 45 seconds. Okay, so we had, first of all, the choice of the wrong sorting algorithm. And second of all, overdoing the work. You can implement I'd rather just import what you need. You can use the merge sort and quick sort code that you find. Insertion sort you can write yourself. It's probably shorter. Just embed it right into your program. The heap sort is readily available. Like I said, the point of the project is not writing the code. Whatever you do, you're going to have to go in there and fiddle around to get the timers built in. Because I don't want to count the operating system steps, just the actual, um, yes, the operating system in that it's switching the data around in that. But I want to see the difference in the runtimes. And, the more stuff you have, the more information you get. What I've always wanted to do with this is just post a document after they're all handed in and let you guys put in your average run times, the average of the 1,000 times you run it. And with the data, what the language was, what the processor was, and just see what we recognize as trends. Are certain languages working better than others, or certain um, processors handling things better? I mean, I don't know about your class, I didn't ask for your specs, but I noticed in two of my classes I did ask for them. And some of you have some pretty high-powered computers, running 4.2 gigahertz or something. I'm still putting around at 2.1. Mine's a 2019 computer. So anyway, this whole thing will be posted as a document, but if you want to start thinking about it, how you want to organize it, what you want to do, what things you want to look up, it's a fun project. And like I said, the whole point of it is not the code. I mean, this is code you wrote in 313. So the code is not a big deal. The important part is seeing how the code you wrote relates to these runtimes that now we're throwing around and what they really mean in actual time. We think of sorting arrays, 1,000 times, and we're actually doing, at least three different sorting algorithms, four between the fixed and the not fixed, and getting that down to like it's running in milliseconds. Like really, wow, it's pretty amazing. We'll do a couple of things about runtime. Um, well, it'll be posted by, I'll have it up between now and Friday. Um, that's what date? That's the 13th. Let's say March 1st. It's like 2.5 weeks, almost 3 weeks. Maybe I'll go to whatever that Wednesday is. So the 28th is a Saturday. Sunday, March 4th. I'll say tentatively March 4th. Midterm is going to be the week of the 16th. It'll either be Monday or Wednesday, obviously. Um,
Professor, when is our
yeah.
next quiz? I mean,
I don't know that there won't be a quiz next week because you're going to be brain dead on Wednesday. I know that. A whole week off, it's brain dead. Maybe the 2 weeks from Monday. Yes, last Monday. There's no point in doing something when you've been off. I mean, I could do it, but then I have to grade it, and it's just sad. I don't want to be sad. So yeah, I mean the quiz will be basically something with little o, little omega, and theta. Something short, just to do like 15 minutes at the end of a class. Okay? My attitude towards quizzes is if you're just keeping up with everything we're doing, a quiz is no big deal. And even the midterm, because yes, there will be stuff you have to study, but some of it is what I call adventures in algorithm land. Will be just something creative to do, where my main object is how are you thinking? Not if you're getting everything 100% correct, but are you thinking about things the right way? Or at least looking to see if things are going to work or not. Oh, why did my chat blow up so much? Oh, because everybody was answering. Okay. I saw the answers popping up on my screen, but I didn't see all of them. Okay, guys. Have a wonderful weekend. I know it's going to be a little icy and rainy a little bit, but it's going to be basically warmer. And I think Saturday and Sunday and Monday is supposed to be nice. You can get outside, get some fresh air. And I will be around at 1:30. I have all hopes of being able to stay awake this time because I'm feeling way better. I mean, obviously I still have the cold, but the other thing is over. Okay, guys.
So Professor, is the office hour just gonna be on this meet at 1:30?
It's it's the same Zoom.
Understood. Thank you.
Okay.